Again, welcome everybody. This is the third session of pre-chemistry workshop. Uh, Today we are just going to continue our discussion that we left off last week on Friday. So without delay, let's start. Before I start, I just want to ask you one more time. Do you guys have any particular question before we start? If you
Yes,
have any question,
yes, I have one question, Professor.
yes.
Do you send the hangout for class today, or we're gonna continue what you sent last week?
Yes, we are going to continue something that I sent you last week because we couldn't finish it.
Okay, thank you.
Yes, so we are trying to we are going to finish that today. So any material that we need for tomorrow, I'm gonna prepare it. I'm gonna send it to you maybe
And
tomorrow morning.
thank you to send us the videos. You did it by YouTube, right?
Yes, because I couldn't figure out the other way.
No, no, no. That's great. That's great. Thank you.
Okay, all right, no problem. Any other comments, question?
Oh, I was just curious. I missed last week, so today is my first day. I was just curious if there's anything I missed, or in terms of I know content, yes, but if there's any assignments or attachments.
Actually, there is no assignment. Of course, this is just pre-chemistry workshop. I'm here to help you guys, explain you all the concepts that you need to know for your chemistry classes that you're gonna take. In terms of handout, I think I must have sent you email regarding, like the link. The email that says link, it should have the attachment in which you say you get two attachment, like three attachment. The two handout that I sent you early, like last sent to everybody last week, and there should be one attachment of the periodic table. So if you don't mind, can you please check the email and see if you find any attachment? If you don't find it, it's okay. You can send me email after we finish this. I can send you all the handout that I have sent all the other students last week.
Okay, thank you.
No problem. Any other question or comment? All right then. Okay. So again, I'm going to write on the screen. So I'm going to turn off my camera. I'm just want to show you my face that this is me. All right. So I'm going to turn off my camera uh, right here. Okay. So without delay, let's start. So let me just ask you, anybody remember what we discussed last week? What we left off, right? We were discussing a one.
I'm sorry to cut you off. We talked about periodic table, and you went over the groups, and then you went over the columns and groups, and then periods, and then you went over alkaline metals, alkaline earth metals, etc. And you talked about group 1A, group 2A, and
Yes.
they're numbered by valence electrons. And then you talked about metalloids,
Yes.
and then you talked about in one square, like in one element box, the one is atomic number, and then you talked about atomic mass / mass number, and that's where we left off.
Yes, thank you so much. And that's right. Yes, so if you guys remember, the last point that we discussed was about one box that you see in the periodic table. The each box that you have in the periodic table, again, it is called an element. Every box in periodic table, right? Every box you see in periodic table individually, they are called as any element. If you see a general format of the box, this is how you see in general. If you Google the pictures of periodic table, you may see different images and it may have like different arrangement, but in general, you see a number on here. Let me just say it 1. You see a symbol of an element. So H, we're just going to start with a simple one. The name of an element, which is hydrogen, and at the bottom you see a number which has a decimal place, right? Which could be 1.00 or 01 or something. All right, again, I'm not saying that this number are correct, but I'm just saying that this is how you see in general, right? So in that case, right, if when you say this, you should know what information you can extract from this. So this box, right, the number 1 that you're saying in this periodic table, this number goes up sequentially. 1, then is 2, then 3, then 4, then 5, and so on up to 118, because till now at that moment we know 118 different elements, right? So this goes on sequentially, like 1 2 3 4, right? any number that goes up sequentially in the periodic table, that number is called atomic number. All right, atomic number. All right, of course you guys see this is called symbol of an element, right? What is the general symbol? Remember that when you write the symbol, if there is only one letter, it must be capital letter. If there are two letters, then the first one must be capital, the second one must be the small letter. All right, so keep that in mind. We will discuss that later, right? This is, of course, this is the name of an element, and the number that you see at the bottom of the table, in general, the number with decimal point in it. Remember that the number with decimal point, that is called mass number, right? It is also called as atomic mass, right? Depending on which chapter you're talking about, we can kind of interchange this kind of definitions, right? We can interchange this description, that sometimes we call it as a mass number, sometimes we call it as an atomic mass. Do you guys understand this? Do you guys recall this?
Yes, sir.
Everybody? Yeah.
Yes, Professor.
Yes, we remember
Yes,
that.
Professor.
Thanks.
Okay.
Yes.
Great. So this is where we left off, right? So let me just explain you what is atomic number, right? So atomic number means the number that goes up sequentially, and this is the criteria on which the elements are arranged in the periodic table. So you see 1, 2, 3, 4, right? So based on what this element are arranged in the periodic table that you see, remember that is based on atomic number, and atomic number is equal to number of proton. All right, so before we talk about this definition, I'm going to explain you what is proton and everything else, but I just need to explain you what this stands for, or what we can understand from this. The other number that we should know is called mass number, right? What is the mass number? Mass number is equal to number of proton plus number of neutron. So this is something you must keep in mind, that atomic number is equal to number of proton, mass number is equal to number of proton plus number of neutron. All right, before I explain you more in detail, I have to explain you what is this proton and neutrons are. All right, so do you guys understand this part at least, right? Can you guys remember this? Number of atomic number is equal to number of proton, and mass number is equal to number of proton plus number of neutron. Can you guys remember this?
Yeah.
Everyone?
Yes. Yes.
Okay.
Yes.
Great. Just in case if you write something in a chat box, sometime I may not see if it doesn't pop up. And if you guys have any question, please shoot. Or if I do not answer your question, if you put it in a chat box, please reiterate, and I'll be happy to answer that. Okay. So,
Okay.
Great. So I'm gonna erase the screen for now and just go back. Okay, let me just erase. Oh, I had to erase it manually. Oh. Okay, so clear. Yeah, clear all. Okay, so what we're going to discuss now, we are going to talk about, where is my that draw? All right, so now we are going to talk about what is an element and what is a compound, before we talk about proton and neutron. All right, so you must know what is an element by now, right? Can you guys, anybody can answer this? Anyone? What is an element in general?
Each box in a periodic table.
Right, every box in the periodic table, that's right, that is called an element, right? So everybody must have seen copper, right, or iron, right? So let's say this is a piece of copper, right? This is a piece of copper. Now if you have this piece of copper, what could be the difference between this? It is still copper, right? If you have smaller piece, it is still copper. If I just give you a tiny piece, it is still copper, right? Do you follow me? If I just give you a very tiny piece, it is still called copper. So what I'm trying to explain you is the smallest particle, right? The tiniest portion of the piece that still reflect all the properties, or we can say characteristics, of an element, right? The tiniest piece or particle that has all the properties of that particular element, it is called atom. All right, so what is that? It is tiniest particle, right? Or I would say smallest particle. That is more scientific. So smallest particle of an element which carries all the properties, right? Which do all the function that that particular element can do is called an atom. All right, so this is something you need to remember. Okay, do you understand this part?
Yeah.
Everyone?
Yes,
Yes.
Yes. Yes, Professor.
Wonderful, wonderful, great.
Yes, Professor.
All right, excellent, right? Now we're going to talk about what is a compound. So compound is very simple. When two or more element, right? Two or more, two or greater than two, right? Basically greater than equal to two. Two or more element join together or comes together and form something, right? I'm just explaining you in a very simple terms, right? When two elements join together and form something, that is called compound. Simple, make sense?
Yes, sir.
Yeah.
All right, so when you had one element that by itself, it is called an element. When there is two elements coming together, then it form a kind of substance that we call as a compound. Now for the compound, we can apply the same concept that we just learned here, right? Let's say compound is H2O, right? Do you guys know what is H2O?
Yeah.
Water.
Water. I think everybody know that, right?
A
If you
compound.
sorry.
Water.
Yes,
Compound of water.
right. Of course, right. If you don't know, now you know, right? H2O is a water. So in this case, right, let's say if I give you a container in which I filling up this water, right? This much is water, or I'll just give you a little water or just one tiny droplet of water, right? But what is that? It is still water. Even if it's tiny droplet, we can call it as a water droplet, but we still call it water. All right, so the same way, the smallest particle, right, what we can say, the smallest particle of a compound, smallest particle of a compound that again has all the properties of that particular compound is called molecule. You understand? The smallest particle of a compound that carries all the properties or characteristic of that particular compound is called molecule. So this is something you got to keep in mind. The smallest unit or particle of an element is called atom. Smallest particle of a compound is called molecule. Is that clear?
Yes, sir.
Yeah. Yes.
Wonderful.
Yes.
Excellent. All right. So with this, what we're going to talk about now is even in atom, right? Even if we go further in detail, like if even if like let's say if you're trying to look at this atom through the microscope, for example, what do we see within the atoms,
All
right?
three things.
Inside the atoms, yes. So we see three particles in the inside the atoms, right? What
Yeah.
are they? Do you know that?
Yeah, proton,
Like.
neutron, and electrons.
Right, excellent, right? If you know it, it's nice. If you do not know, now you know. So the atom is basically consist of three particles. What are the name? The first name is proton.
Yeah,
Second one is called neutron,
neutron,
and the third one is called electron.
electron.
So this is something you have to keep in mind. When you look at the atom through the microscope, this is simple explanation, okay? When you look at the atom through the microscope, what do you see? You see three particles. What are they? Proton, neutron, and electron. How this is arranged? So I have to tell you this. We are not going to go in detail with the structure, but I have to tell you this. So basically, when you have an atom, it what basically it has a central, right? It has center basically, and there is an area around this center. All right, so this center is called as a nucleus, right? You must have taken like biology class before, and you may have heard this term before, right? It's a nucleus. Is center of anything is basically called nucleus. So the nucleus is there, which has proton and neutron. So the first two element, or I would say like first, sorry, not element, of course not, okay. The first two particles that we talked about, proton and neutron, they are present in the nucleus of an atom. Make sense? Everybody?
Yes.
Yes, Professor.
Right? And the area around this, or around this nucleus, right? This is the area where electrons are basically moving, right? Electrons are not like a stagnant. It's not at one place. They are moving around. Okay, so this is the area, we can also call it as a cloud, electron cloud. This is the area where we find electrons. So it is around the nucleus. All right. Now, let me just tell you this. The proton, this all particle carry some sort of charge. What are the charge that proton carrying? Proton carry
Positive.
simple, right? I think you guys know that. Excellent. P stand for P, right? Proton is positive. That's the way you can remember if you don't know yet. Neutron sounds like a neutral, right? So does not carry any charge, right? So do not carry any charge. Like neutron sounds like a neutral, all right? And electron carry negative charge, all right? Do you guys understand this? And can you guys remember this?
Yes.
Yes.
Professor.
Yes.
Excellent. Any question from this before I erase this?
No, Professor.
You said the proton carries a positive charge.
That's right. Proton carries positive charge. Basically, we can call it positive one. Each proton carry positive one charge. Each electron carry negative one charge. So in simple word, we just say positive charge and negative charge. All right.
Yeah.
Okay, so now I'm gonna go back to the atomic number and mass number to explain you more detail, because now you know what is proton, what is neutron, and you know what is electron as well. Okay, so I'm gonna erase this. I'm gonna go back to the formula that we talked about. What is atomic number? Again, atomic number is equal to number of proton. So, right? What is mass number? Mass number is equal to number of proton plus number of neutron. Okay. Now let me just ask you, do you guys have your periodic table handy with you? All of you guys?
Yes.
Yes, of course.
Yes.
Okay, if you don't have it, I'm gonna give you 1 minute to make sure that you have it handy. All right. It should be in your email attachment. If you attended this session last time, then you must have like download or something. All right. If you have printed out, it's excellent. If you haven't, then I'm going to give you 1 minute to make sure that you have the periodic table handy with you. All right. And the question I'm going to ask you is, I'm asking you to find out one element from the periodic table, and I want to know what is the atomic number for that element. The name of the element, or I would say the symbol of the element, is F. All right. Do not answer this question. I'm going to give you like 1 minute, entire 1 minute, to let everybody find. All right. So do not answer your question if you can see it right away. It's fine. I'm not giving you like, it is not something down in the periodic table. It is somewhere very on the top of the periodic table. All right. So try to find it in that area. All right. I'm going to give you 1 minute, and then we're going to discuss. Okay.
Can we type it or just keep quiet?
No, just find out, right? You don't have to answer that. Yeah, you don't need to type in as well. Don't worry.
You just need us to identify it.
Yes, I just need to find out element F in your periodic table. All right, I hope you have found it. So now let me ask you, what is the atomic number that you see in that box? Everybody.
9.
Fluorine.
9.
9.
9.
9. Excellent, excellent. Right. So you know how to find out atomic
18.998.
number. You did not read the mass number. That's great. All right. So keep in mind the number that you read is right. Yes, atomic number for fluorine is 9. That's excellent, right? Based on the formula that we just mentioned here, what we can say in the fluorine, it has 9 proton. Makes sense?
Yeah.
Will you agree? Everybody agree? Based on the formula that we just
Yeah.
saw here, what we can say, atomic number is equal to number of proton. It means the fluorine will have 9 proton, right? What is the mass number for fluorine then? F?
18.998.
18.9?
98.
990. Okay, 98. Is it?
Yeah, 998. Yeah.
18.998.
Okay, that's right. Right. So yes, this is the mass number. What does it mean? It means it will have this many number of proton plus neutron. Is that right?
Yeah.
Yeah, Professor.
Okay, so let
Sorry,
me.
I don't
Sorry?
know where the 18.998 came from.
It should be at the bottom of the periodic, the bottom of the box where you see F. You see F on the second period, second to the last
Yes.
column.
Yeah.
And do you see a number at the bottom of that box?
Yes, 17 or something.
It's a 17.
Oh,
Okay, let me see.
17 line first box.
Okay, so the one that I share has 18. Okay. So I think are you using a different periodic table than what I sent it to you, right?
yes, let me get the one you said.
Excuse me?
Right. If you're using another one, it's completely fine, right? It is not necessary that we have to use the one that I sent you, but it is the same close number, right? It is pretty close. It could be like 17. What number do you have? 17 point?
Just 17?
It is 17. Okay.
Uh,
Then, yeah, go ahead. Somebody.
Professor?
I
Yeah.
think she's saying the atomic number of fluorine.
Yeah, for chlorine.
Yeah,
Okay.
that's
Yeah.
why she's
But
saying 17.
yeah, it can be 17, just 17, right? It cannot be that.
Professor?
Yes.
Question. So does that... I see it now. I've seen it. Thank you.
Okay, no
It
problem.
should be like 9.
Professor?
Yes, go ahead. Question. Yeah.
That mean that when you subtract 18.998 minus 9, that's the number of neutrons? Or no?
That's right. That's right. We are going to talk about that now, right? So what is the mass number? You know the formula for the mass number right here. So simply by knowing the form symbol of an element, you can determine how many what is atomic number and what is the mass number. From atomic number, you can extract the information saying that this is the number of proton. From the mass number, you can find out the information on number of proton and number of neutron, right? So according to this formula, you already know what is the mass number. So it is 18.998. You already know the number of proton because you know the atomic number, right? So if you plug in this value, and this is something you have to find out, right? Which is, I will say this
Can
is
you stay on the slide?
of neutron. Sorry?
I was asking if you could stay on the slide.
What do you see right now?
We see the board, the whiteboard.
Notes.
Is it? I thought like
Sure.
No, I'm seeing the board.
Yeah, I'm seeing the board too.
So, no, yeah. I just wanted to write it down. If you wouldn't mind leaving the board up. It's not that important, mister. Sorry.
Okay. I thought like whiteboard is on, right? You guys can see the whiteboard, right?
Yes.
Yeah,
Yes.
I can see it.
Okay, great. All right, so right, what you guys can do in here, you can find out the mass number just by looking at the periodic table. You can find out the atomic number just by looking at the periodic table, and you can use that atomic number as a number of proton. So by plugging this value in this formula, the mass number formula, you can find out how many number of neutrons are there. Can you, right?
Yeah.
Right. So what should be the answer? How many number of neutrons should be there in a fluorine?
9.998.
Right, 9.998. So basically we can call 10. Always remember, I know the mass number is always like this. You have the decimal place in it, but whenever you find out the number of neutron or number of proton, it must be a whole number. So you round it off to the closest whole number. Make sense? All right.
I have a question. What number is circled on the or enclosed after the 9 plus?
9 plus. Okay, that's a question mark. So this is something we have to find out. That's what I said.
Got it.
Yeah, this is like a question mark. What we need to find out. We need to find out what is the number of neutron. That's what I mean. Yeah. So yes, we did find out by using these two formula that what is the number of neutron. All right. So in the exam, you can see this kind of question. Yes, Sukhvir.
I'm just confusing. How we get the 9.998?
If you just subtract 18 point, if you subtract 9
18.998.
998, yeah.
Oh, okay.
Yeah. Get it?
Yeah.
Wait,
Thank you.
Professor, I thought for some reason in chemistry that if you were to round a number from the higher value, that's not basically 10 is not equivalent to 9.998.
That is right, right? Like it is not equivalent if you are measuring something.
Adding more
number,
particles.
right? When you say the number, like if I say how many oranges do you have, you can say like either 2 or 3, or you can say like 2.5. You cannot say like 2.2, right? Make sense?
Okay.
But
so something like that, because we are counting number of proton and electron and neutron. It must be a whole number. So only this concept, yes,
so
you are rounding it off.
wouldn't the this is just a literal question, but wouldn't the correct answer would be 9, not 10?
No, this is like 9.99, right? So
yeah, it's not 10 though.
It is 10.
Yeah, what
it's
I said,
close to 10, but it's not 10.
Yeah, so you have to round it off to the closest whole number. That's what I said, right? Yeah, that's how that's what it is. If you end up with like, actually in the exam, you know, when the mass number is given for this particular question, they won't give you 18.99. They will generally give you as 19. All right, what I'm trying to do, I'm trying to explain you to how to read or how to find out the mass number. So I kind of stick to the number that we found on the periodic table. But in an exam, let's say if I'm going to ask you this question, all right, so let me just erase this. I'm going to show you one more time.
So shouldn't we identify if we should round it to the nearest 9 or to the nearest 10?
It has to be the closest to the whole number, whichever it is. If you see a number like 9,
we round it up.
Then you round it off to 9. If you see 9.6, you round it off to 10.
That makes sense.
Yeah.
Somewhat. Yeah. So if it's not, so you round the higher the value in the decimal point. Anything above 5, you round up. Anything below 4, you round down.
Correct. Right. The same rule that we follow for the math, right? The same thing. Yes.
I was confused there.
Okay, now it's clear, right? So great. So let me just show you the way you can see in the exam, right? So I can give you, okay, let's find out number of proton, number of neutron, number of electron, for an element. The symbol is capital N, small a, Na. All right, and you have the periodic table with you.
Great.
All right, so we have, all right, let me just point this out right now. we haven't talked about how to find out number of electron yet, but we are going to discuss that in this problem. Okay, so but at least at the moment you should be able to solve what should be the number of proton and what should be the number of neutron. So I'm going to give you 2 minutes to find out the element in the periodic table. Use the formula that I just explained you. In case if you do not have the formula, I have given you that formula in the handout as well, so make sure you keep your handout handy with you as well. All right, and try to see if you can get to the right answer. I'm going to give you 2 minutes to work on this. Okay.
Random?
Okay.
Professor?
Yes.
We pick at random, you said?
Can you repeat your question?
We just picked an element at random?
No, I gave you, this is the element. This is the symbol of an element. And
Na.
yeah, this is the symbol of an element.
Yeah, sodium.
All right, guys. And at the moment, if you're not using your microphone, please kind of mute yourself. Right. If you have any question and if you want to use it, please turn it on and use it. But if you're not using it right now, please mute. Thank you.
Professor, have we gone over how to find the number of electrons yet? Or are we still waiting on that?
No, we are going to discuss that in this problem. I haven't talked about that yet.
Okay, thanks.
Yeah, no problem. All right, so I think it was enough time. All right, so let's just solve this together. Na. All right, can you guys let me know what is the atomic number?
11.
11.
11.
Great, right? You can always find out atomic number from the periodic table, which is 11. What does it mean?
11 protons.
That's right. It means the number of proton is going to be 11, right? What is
11
the next number?
electrons too.
Yes, we are going to discuss that. But what is the mass number that we found out for Na?
22.990.
Sorry, 23 point
22.990.
22.990. Okay, right. So that's right. Now we can just say that mass number is equal to number of proton plus number of neutron. We already know what is the number of proton. It is 11, right? Plus number of neutron. So if you kind of, do the math, if you want to get rid of the 11, it means you subtract 11 from this side and the other side, right? You get your answer, which is should be what?
11.99.
Right? 11 and minus 11 cancels out. That is going to be the number of neutron. So as I just told you, you round it off to the closest whole number.
So 12.
So this should be 12. That's right. Everybody follow me? Yes.
Yes.
Yeah.
Everyone?
Yeah.
Yes.
Excellent, excellent, right? So yes, this is the way we can find out what is the number of proton and what is the number of neutron. Now we are going to talk about how to find out number of electron. So remember, you remember we talk about this, that this box, each box in the periodic table is called an element. If the symbol given you as an element like Na or maybe F, it is an element. So if the question asks you about an element, then you can also say that atomic number is equal to number of proton, and also can say that it is also equal to number of electron. All right, this is true if we are talking about an element. And in the example that we just discussed it so far, the first example was F, the second was Na. Yes, this is an element. So yes, we can say that the same number of proton that we found out in both of the case, that is the same number of electron. So in this case, number of electron is going to be equal to
11.
That's right. It is also equal to 11. Why? Because the atomic number was 11. Does it make sense?
No, I'm confused.
So all I'm trying to say is atomic number is not just equal to number of proton, but it is also equal to number of electron.
When it's neutral, right?
Yeah, only when we are talking about an element. All right, so this is the element, right? In the both examples that we talked about so far, F, fluorine, is an element you see in the periodic table. Na is an element you see in the periodic table. What is not an element, or in which scenario this is not true? If we are talking about ions. If we are talking about an ions, then in that case, this is not true. What is not true? Atomic number is equal to number of electron. That is not true. Why? And how do you know what is ion and what is an element? All right, so let me explain you. Element is the symbol of an any element without any charge. So if I'm going to talk about Na or F, this is all element. If I just give you the same symbol, for example F, and I give you a sign, a negative sign as at a superscript, right? There's some sort of charge on a superscript of that symbol, then this is called ion. For Na, if I give you some sort of charge, plus charge, now this is ion. All right, this is ion. Make sense?
Yeah.
Yeah.
Yes.
All right, so
What is the atomic number, mass number though?
the atomic number is same, right? The atomic number is same, the mass number is same. It will change the number of electron, and we are going to talk about that in the next whiteboard. All right, but let me just explain you one more time here. That is an ion. So what is the difference between element and ion? Element does not carry any charge. All right,
Element is neutral.
There is no charge on this symbol. That's right. All right, if you see any particular symbol from the periodic table and it does not have any charge, then it is an element. That's simple. Every box in the table does not have any charge, like Fe, Cu, this does not have any charge. But let's just say if I'm going to put some sort of charge, +2, +1, now this become ion. And if it's an ion, then this is not true. Everything other than this is true. It means if I'm going to say if it's an ion, atomic number is equal to number of proton. So yes, even if it's ion, it is true. For mass number, it is still the same formula. That's true. It is just not true for number of electron. Does it make sense?
How did you find, just in terms of the one that we're doing now, because it's just an element, how did you find the number of electrons again?
It is same as number of, it is same as atomic number. All right, so let me just erase this and I'm gonna rewrite that. Like I'm gonna put everything together now. All right.
Isn't the atomic number the number on the bottom?
No, the atomic number is generally a whole number which does not have any decimal point. It could be located anywhere in the box, depending on which kind of periodic table you are looking at. But remember, atomic number does not have a decimal place in it. Get it?
So how did you find it? Oh, it's the number of protons? Is it?
So do you have the periodic table with you right now?
Yes.
Yeah. So if I'm going to ask you He, can you tell me what is the atomic number for that? He.
Helium.
Yeah, you don't have to look that far. It should be on the right side.
Which one?
2.
He. What is the atomic
Helium.
number?
Oh, 2.
Yeah, that's right. So you know how to find out atomic number.
Yeah.
Oh, I see. I got it.
Get it? Yeah. Okay. Great.
So my biggest struggle was calculating the total amount of charges or extra ions for an isotope.
Okay.
Like, how would I find a charge for an isotope?
All right. So we haven't talked about isotope yet. So we are going to discuss that. Yeah. So in terms of isotope, there is no charge. Isotope is again same element which has different number of neutron in it. So once we finish discussing about this, we are going to talk about isotopes. Okay. So I'm going to explain you. If you have any question after that, please ask me. Yeah. Okay. So for element and ion, what is the difference? So everything that you see in a periodic table, like H, maybe He, right? Na, F, for example, Cl. This is all element. It does not have any charge, right? If it does not have any charge, what we can say, atomic number is equal to number of proton. And for an element, we can also say that atomic number is also equal to number of electron. All right. So if we have to find out, oops, what happened? If we have to find out number of proton or electron for an element, all we need to know is atomic number. And the mass number, I think everybody know that. Mass number is equal to number of proton plus number of neutron. All right. Now, what is an ion? Ion is basically carry some sort of charge with the same symbol. So H, if you have some sort of charge, plus charge, right? We cannot talk about He because it does not form any ion, but Na carry plus charge, F carry negative charge, Cl carry negative charge, oxygen carry -2 charge. All right. So if I give you any of this or many other than this, of course, what you can say, this is an ion. If it's an ion,
Yeah.
what is the truth? This is still applies, right? Atomic number is still equal to number of proton. So in this case, right, let's try this, right? Let's try for Na and Na plus, just to make sure that we understand this. For Na, number of proton is going to be what?
11.
Yes, you see there is a number which is atomic number, that is 11. So we can say the number of proton we have in Na is 11. The same thing we can say if it's even if it's an element iron, we can say the number of proton is 11.
Yeah.
Okay. The second truth is number of neutron. All right. So what is the mass number? As we know, it is around like 23, right? So 22.99. What is the atomic number? It is 11. So we did find out earlier that it is going to be 12. So number of neutron is 12. Do you guys follow me? Everybody?
Yes.
This is just what we did earlier, right?
Right.
So this is true for ion as well. So number of neutron is same thing. Mass number
12
minus atomic number is equal to 12. That is true. Okay. Now what do we know? We can, if it's an element, which is in this case, then atomic number is also equal to number of electrons. So this is also going to be equal to 11. All right, but that is just not true for an ion. Why is that? Because how do you form ion from an element? So if there is an element, if it want to form ion, it has to either lose electron or gain
Or receive.
So basically you can say exchange. Yes, that's right. Right. So some element in the periodic table like to lose their electron to become ion. Some element in the periodic table like to gain an electron to become ion. Some element does not like to form ion at all. So the last group we have in the periodic table, which is called noble gas, 8A or 18, group number 18, that does not form any ion. They are happy as an element. Okay, but everything other than that generally form ions. Okay, do you understand this?
You said the noble gases do not become an ion?
Yes.
Okay.
Right, that's why I did not talk about He as a ion here, because He is a noble gas and it does not form ion.
Oh, professor, but if you like set up the temperature or pressure, they do form some.
They do form some sort of molecular compound, but not ion. They do not carry charge.
So is there a number of electrons for the ion?
Yes, so we are going to talk about that, right? So do you understand this, right? What we have to do from element to become ion, either it has to lose the electron or gain the electron. Now
the concept is clear, but my question for a reasoning of why the noble gases have no charge is like, as long as there's an electronegativity present, there's an ion, I'm guessing.
Can you repeat your question?
So my question is like, why is a noble gas not an ion?
All right, so they do not like to lose any electron and they do not like to get any more electron, because every element will like to have 8 electron in their valence shell. We haven't talked about that, so it's kind of hard for me to explain this to everybody, right? If you know the basic, you may know what is valence electron, right? And every element like to have 8 valence electron. Noble gas already has it, and that's why they don't like to share or like lose or gain any electron. All the other element, they like to either donate, accept, or kind of share electron. Why? Because they all like to have that 8 electron in their outermost shell.
So the process, the electronegativity can be related to the process?
Electronegativity is totally different thing. Electronegativity is a whole different concept. If you have like some question, like, you know, which we haven't discussed, you can leave it for the end. I'll be happy to answer that. Yeah, if you have any question regarding this, of course you can ask me, but electronegativity and that concept is totally different than this. Yeah.
Yeah, well, it's just the inner questions that I'm asking. That's it.
No, I understand that. So that's why I say all the noble gas, they do not like to share, they do not like to make any form of ion. Why? Because they have that 8 electrons in their outermost shell. That's why they are kind of inactive and they are happy what they have. If we are going to talk about noble gas, they do form some sort of molecular compound in which they share their electron with another noble gas atom. But that is totally different, which we haven't talked about yet. So I cannot, like, you know, explain you the other detail which I haven't talked to the all of you guys. But does it make sense?
Yeah? Makes sense. Makes sense.
Okay. Okay, great. Yes, someone else has a question too.
Professor, just a quick one. Is that the reason why they're called noble gases? Is that the reason why they have that name?
Yeah, noble gas is something, you know, they are like kind of chilling, you know, like they have nothing else to do with all the other element. They are just happy with the way they are. Right, and the reason is, right, we haven't talked about the elements like the valence electron, so I'm not going to go in detail, but I can still tell you that all the element in this periodic table, why do they form an ions, or why do they form compounds, the only reason is they want to have 8 electron in their outermost shell. I haven't talked about what is outermost shell, but we can just keep in mind that if when I say this is nucleus, right, and this is the cloud where the electron can, where we can find the electron. So the outermost area where you can find the electron, that is called outermost shell, or we can call it as a, let me just write it down, outermost, we generally call that area is a as a shell. Okay, so electron that we have in this area, that is called valence electron. So let's say if we have some number of electron in this area, right, this electron is called valence electron, and this shell we can also call it as a valence shell, or we can call it as a outermost shell. All right, so why does this element form ions, and why does this element form compound? The reason is every element will like to have 8 electron in their outermost shell. So this is 4 and 4. To attain this status, right, to attain this state of 8 electron, or having 8 electron in their outermost shell, they are doing this kind of like, transition. Maybe they are forming ions, maybe they're gaining electron, maybe they are losing electron, they may be charging, like they have positive charge or negative charge, or sometimes they share electrons. Okay, so that is the whole point of having this element and forming compounds and ion. Is that clear?
Yes.
Yes.
Yeah.
One question.
Yeah, go ahead.
Is the mass number proton and neutron equal outside of valence, like in the valence electron shell, or like the inside the nucleus shell?
It is always within the nucleus, right?
Okay.
Proton and neutron are always present within the nucleus.
Okay.
Everything outside the nucleus is only electron.
Okay.
All right.
That's good. Thank you.
Yeah, no problem. All right. So again, what is an ion? So because I have already explained you this valence shell, so let me just go a bit more in detail to explain you that how this element is forming ion. All right. So that way it could be you have all your answers and you think that you already understand this material. All right. So do you follow this? Do you understand this part, everybody?
Yes, sir.
Yes, Professor.
Yeah.
Yes, Professor.
Okay. Excellent.
Yeah.
I'm sorry. So just to what you said in the top right corner with the valence electron, you're saying that that's the outermost shell that deals with the ions or something, and then is
Yes.
that what?
So we are going to talk about that. Yes, but
Oh,
the
okay,
valence cell, valence cell are the one which is going to lose electron or gain electron. Okay. So let me just clear this screen. I'm gonna explain you one more time more in detail. So you guys already know what is an element and ion, right? So when I say Na, we already talk about that, and this is going to be Na plus. Now the first thing is that, or you already know.
Nothing here, man.
Sorry.
My bad. I didn't know the mic was on. I'm sorry.
Oh, okay, no problem, no problem. All right, so this is, all right, I'm just gonna point this out in number of proton, number of electron, and number of neutron is here. For this, we did find out number of proton, it's going to be 11. Number of electron, we haven't discussed that yet. And number of neutron, it is going to be the same. All right, now let me just show you. First of all, we say Na plus 1. Why? Because sodium Na, right, it is always forming plus 1 charge. What does it mean, right? We're going to talk about that first. So there are some elements which form positive charge, there are some elements which form a negative charge. Okay, why is that, or what does it mean? It means Na lose 1 electron. If Na lose 1 electron, let me just point this out in the opposite direction. If Na lose 1 electron, it become Na plus. Why? Because electron generally carry negative charge. If you gives off one of the negative charge that you have, what you're going to end up with? You're going to end up with positive charge. Does it make sense?
Yeah.
Sure. So when we talk about forming an ion, we are only going to talk about exchange of electron, all right? Not about proton. It's not exchanging any proton. It's not exchanging any neutron. It is only exchanging electron. And we know electron carry negative charge. So now let's say if any element is going to lose electron, it means it's going to have less of the negative charge. If it's going to have less of the negative charge, it means it's going to become positive charge. That's why when Na lose one electron, it become Na plus. Does it make sense?
Okay, got it. Thank you.
Right? Great. Same thing for F. What they like to do, they always like to gain one electron, right? If you gain one more electron, it means you are gaining a negative charge. That's why you becoming negatively charged. So now it become F minus. Do you follow this?
Yes.
Yeah.
Yeah.
Is there a
So,
specific way to identify it as negative or positive?
yes, of course, right? So that's what I'm going to point it out here. You remember this is a group number that I talked about, right? Not 8, 7, 6, and 5. All right, so these are the specific group number. If you remember, there is 2 ways to label the group. There is starting like 1, 2, 3, 4 up to 18, and there is another way in which we're just going to skip the middle portion of the periodic table and label as 1A, 2A, 3A, 4A, 5A, 6A, 7, and 8. So always, 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 always remember this. Any element you see in the periodic table which is present in group number 1A always form positive 1 charge ion. This is true always. It will never become a positive 2 charge ion. So this is something you got to remember, right? Number 2, if you see any element which is present in group number 2A, it will always form plus 2 charge. Group 3A, some of this is falls under ionic metal category, some of this falls under non-metal category and metalloids. So we are not going to talk about all of them, but in 3A we can specifically talk about one element which is the Al, which is called aluminum, and that is always, always, always going to be carrying plus 3 charge. Always remember this. This is very, very handy when you're going to name this kind of compound. All right, and we're gonna learn that today later on.
You're saying only aluminum has plus 3, or the whole group has plus 3 for 3A?
Let's just keep as a aluminum, because if you see the element right underneath the aluminum, that sometimes falls in a under metalloid, and everything below that sometimes they do not form any ionic compound. All right, so we're just going to skip those. Let's just keep as a aluminum. All right, so in group number 3A, which is aluminum, it is always going to form plus 3 charge. All right, group number 7A, right, second to the last group, it is always going to make negative 1 charge. That's why I say F. I said F minus. Why? Because it is in group number 7A, right? It is always going to make negative 1 charge. Group 6A, negative 2 charge, and group 5A, always negative 3 charge. All right, again, when we say negative 2 and negative 3, we generally apply this to, let's say this is going to be for oxygen and sulfur. Beyond this, it falls under metalloids, so we cannot talk about that. So we can stick to this rule, right? And for this is going to be nitrogen and phosphorus.
And sorry, I may have missed this from last week, but how do you know what's in 1A or 2A, or how do you define those groups based on looking at the table?
You just need to keep your periodic table handy with you.
But I guess where does it say that it's 1A or 2A?
Okay, so if you don't mind, can I answer that question later on? Yeah, because I discussed that in the previous session, and you can review that session if you want, or if you still want to answer, of course I'll be happy to answer that at the end. Right, it is a different way to label the periodic table. Okay, I'm going to explain you later on. But I can say, okay, let me just rewrite this group. This is 1, group number 2, group number 3. So this is what you're saying. Sorry, I couldn't see your name, but this is the actual group number that you might be seeing on your periodic table, right? It could be like this: 1, 2, 3. This is 15. Instead of 5, it is 15. Instead of 6A, it is 16. Instead of 7A, it is 17. Okay.
Didn't you say that 3 is the group 13?
Oh, sorry, my bad. Yep, that's right. Thank you for correction. Yes, my mistake.
And where does group 4A lie in this, or does it not count for the valence electron?
Yeah, it does not count for forming ion because it is going to generally form a molecular compound. It means they are going to share electron.
Okay.
So, all right, so we are not going to talk about that as an for the ions. All right, so let me ask you one more time. Do you guys understand this, and will you please remember this? Very, very important information.
Yeah.
All right, so if you can remember this way, it's kind of easy. Group 1A, 2A, 3A, it has +1, +2, and +3. Group 7A, 6A, and 5A, -1, -2, and -3. All right, everybody understand this?
Hey, Professor, I have to go. I'll send you an email after the class is over. Is that okay?
Oh yeah, sure, no problem.
All right, man. Thank you.
All
Have a
right.
good day.
You too. Bye bye. All right. So everybody understand this part?
Yes.
Yes, Professor.
Yes.
Professor, can you put the board a little bit up because I can read the information in 17.8 group?
Okay, I can
Maybe
read
it's-
the board, but I will make sure that I do not write something on a kind of edge of the screen.
Oh, okay. Okay.
But for now, I can just rewrite that. The last one, I said 7 or 7A, always carry -1 charge.
Okay.
That's all it says.
Okay, thank you.
Yeah, no problem. And I'll keep it in mind.
I have a question. Like when you write Na plus, does that mean Na+1 and you just don't have to write the number 1?
That's right. If it's just 1, you don't need to write +1. You just say plus. If it's -1, you don't say -1. You just say minus. But if you want to say -1, it is not incorrect as well.
Okay, thanks.
Yep, no problem. All right. Now let me explain you why this charge only. All right. Why do we say Na is always +1, right? We understand the rule that, okay, this is what it is, but why? So I'm going to explain you very briefly. Remember, we don't have the basic information for this, but because you were asking me the question, so I'm going to explain you this. So this is the nucleus in which we have proton and neutron, right? We are talking about Na. Then it's going to be an area, the first shell, or we can say the first energy level, right? Again, do not worry about this term. You are going to learn this in your lecture. As I told you, we haven't talked about that, so it's kind of off. But this is the first area where you can find electron. And in the first energy level, or you can say first shell, let me just write that down, energy level, or we can also call it as shell. All right. In the first energy level, you only have 2 electrons. So there could be electron 1 and there could be another electron 2. Okay. At this moment, I think I should change the color so you know this is electron. Right. So in the first shell, it is something you're gonna learn later on in the class. But first shell can only have 2 electrons. All right. Every other electron that you may have, that you're gonna put it in the cell after that. That's the second shell, right? How many maximum number of electrons it can have? 8. So it could be 1, 2, 3, 4, 5, 6, 7, and 8. All right. The first shell, the maximum number is 2. The second cell, the maximum number is 8. All right. Just for the purpose of this course, we can say that this is not exactly right, but again, just for the purpose of this course, we can say the third shell can also have 8 electrons. So we can have the third shell, right, and 8 electrons. But let me just remind you one more time. Na, what is the number of electron, or how many electrons do we have in Na?
11.
Right, 11. In this diagram, how many electrons did we arrange already? So you see 1 and 2 in the first,
10.
and 8 Yep, that's right, right? So 2 in the
One.
first shell, 8 in the second shell. So how many more electron do we have to fill in this the third shell?
One.
One.
Just one. All right. Now what was something that I was talking about? I said, like, again, we haven't, this is kind of going off the topic, so it's kind of I have to explain you all the octet rule. All right, so something that I said, that every element will like to have 8 valence electron in their outermost shell. That statement is called as a octet rule. Octet means 8, right? Octet, I think you may have heard this term. Oct means 8, right? Like octopus, 8 hands, right? So that's called octet rule. So every element in the periodic table will like to have 8 valence electron in their outermost shell. There are only 2 exceptions for octet rule, which is the first 2 element, hydrogen and helium. These are the first 2 element, and they can only have 2 electron, right? So these are the only 2 exception. As long as hydrogen and helium has 2 electron, they are happy. But every other element in the periodic table, they will like to follow 8 electron in their outermost shell. In this case, for Na, the example that we are talking about, what do we have? We have 1 electron in the outermost shell. Do you follow me right now? Right? You guys seeing this? Everybody?
Yeah.
Yeah.
Yes, Professor.
Great. So what does it mean? It means to complete the octet, either it has to gain how many more electron?
7.
7 more,
Mm-hmm.
right? Either it has to gain 7 more electron to complete its octet, or to have 8 electron in the outermost shell, or it has to lose how many electron? 1 electron to complete its octet. What does it mean? It means we're just going to get rid of the outermost shell that we're seeing right now. You see this? So if we just get rid of this shell, right, it means if we just lose 1 electron, which was here, right? Now in this case we can say, yes, now this Na has 8 electron in its outermost shell, because once this electron is gone, there is no place for the shell. This is imaginary shell, right? So now if we don't, this shell does not exist anymore because there is no electron. Do you follow me?
Yes.
Yeah.
All right. So
you can, I'm sorry, and you can only have up to +3 as maximum, or lose 3 maximum. So that's what it's gonna lose.
yes, that is the general case. Yes. If it's 4, I'm going to explain you that as well. For carbon and other element, when it close to 4, I'm going to explain you that. Okay. Yes. So that is right. It can have +3 or -3. All right. Let's look at this. Which option, if I'm going to ask you, you have to do either one of this, what are you going to do? If I'm going to ask you, either you just give your 1 chocolate to someone, or ask 7 other people to give you chocolate. What is easy for you?
1.
One.
One,
Yeah,
right?
it's to giving
Because,
away.
yeah, it's too much work to get 7 more. So losing 1 electron makes sense. So that's why what it's going to do, Na is going to lose 1 electron. And if it's going to lose electron, it's going to become a positive charge. How many electron did it lose? 1. That's why it's going to become +1. Is that clear?
Yes, sir.
Yeah.
Yes.
All right. So based on this understanding, what you can say, what should be the number of electron for Na? Plus
10.
everybody. What should be the number of electron if I'm gonna give you a symbol as Na plus?
10.
10.
Excellent, right? That's why I said, what did I say? Of course, this is true. Number of, like, atomic number is equal to number of proton. That's true. Let's say if you have +1 charge, it means you are going to subtract 1 from this, 1 less electron, so it should be 10, right? If you have plus, for example, Mg, if it is always going to be +2. Why? Because this is present in group number 2, right? So in this case, for example, let's just assume that this is 23, right? Proton, number of proton is equal to 23. I'm just assuming this number at the moment. And if we had to find out number of electron, what that answer should be?
21.
3. Yes. What actually happened here? Plus 2. It means magnesium lost 2 electron. Lost 2 electron. 21. Do you follow me?
Yes.
Yeah.
Everyone, yeah?
Yes.
Yes.
Well, I think we need to like do more of this kind of problems, you know, to understand. Well, at least for me, to understand better.
Of course, you need more problem, but
Practice.
remember, like this is kind of off the topic right now, right?
Okay.
Yeah, because I have to explain you so many more things before we talk about this. But
All
because
right.
you guys are asking me questions, so I went over this. Yeah.
Yeah. Okay.
Yep.
Thank you.
Yep. We first of all we need to remember these things, right? We should know what is the symbol, what is the name of it, how
Group
how
and
many ions are there, how we can put them together as name and formulas, right? And then we can talk about why this is happening. Okay, but I think I explained you all the kind of background information that you need to know. All right, so this is a bit complex. I completely agree with you, but you're gonna learn this in the lecture anyway, right? So this is just an advanced class that you're gonna kind of listening to this all the information before the class. But if you guys have any question, please ask me right now. I'll be happy to answer that. Yeah.
Professor.
Yeah.
So in 6A, oxygen has the -2 charge. So if it changes to a +2 charge, is that does that stay in a regular ion, or does that become an isotope?
Okay, so first of all, oxygen can never change to +2. It always, if it's forming ion, it is always going to be -2. All right. And isotope, again, as I told you, we haven't talked about that, but isotope is the having a same number of proton, but having a different number of neutron. So for isotopes, the only difference between the two isotopes of oxygen is different mass number. All right, so I'm going to talk about that in after we finish talking about this. Yeah, so I'm going to answer your question about isotope. But remember, if you want to say oxygen can carry +2 charge, it never going to happen. It is always incorrect. As I told you, it is in group 6A. It means if it's going to form ion, either it's going to stay as an element, or if it's going to form ion, it's always going to be -2.
Is that the same for 5A then? It could never do the plus charge. It would always be -3 and then -2.
For which one?
For 5A, is that the same?
Oh yes, always -3. If you're talking about ion, then yes, always 3. If it's forming a molecular compound, it is a different story, right? But not ion, no charge. Yeah. All right, so let me just show you why oxygen is going to be -2. So just to make sure that you guys kind of get the idea, right? So again, for this, I'm gonna ask you oxygen, right?